you are given a 3-digit positive integer. When you reverse the digits of this number, you still get a 3-digit positive integer. The sum of these two 3-digit positive integers is 888. How many such positive integers are there? Okay, well, here's an illustration of what the problem states. A, B, and C are just the digits of the integer that we're given, and then C, B, and A is just that integer with the digits reversed. Okay? So, and when you add those, you get 888. And one thing to note is that we're told that we get a 3-digit positive integer, or well, we're given a 3-digit positive integer, and when we reverse the digits, we also get a 3-digit positive integer. And so that means that both A and C are not 0. Okay, because if A were 0, then we'd have a 2-digit integer, and if C were 0, we'd have a 2-digit integer when the digits were reversed. Okay, so we're going to assume that A and C are not 0. Okay, so another thing to notice is that when we add B and B together, we get something ending in 8. Okay, now if these were like 9 and 9, we'd get a carry, or they could be 4 and 4, and then we wouldn't have a carry. And we can also see that if when we add C and A, we get something that ends in 8. And if we had a carry, the biggest carry we could have would be 1. And then when we add A, or when we add B and B together and add 1, we would have to have an odd number, okay? Because B plus B is 2 times B, which is going to be even. And if we add 1 to it, that would give us an odd number, okay? So that means we can't have a carry when we add A and C together, okay? So A plus C has to be 8 even, and not 18, so it can't be 9 and 9. So we know that we can't have a carry, because otherwise we get an odd number in this middle position. So B plus B is 8, which means the only possibility for B is that B is equal to 4. Okay? Does that make sense? So these numbers are going to have 4 in the middle. We know that. And then A and C have to add up to 8 without any carry. Okay? So they just have to have, so they just have to add up to 8. So our possibilities are 1 plus 7 is 8. We have 2 plus 6 would be 8. 3 plus 5 would be 8. And 4 plus 4 would be 8 also. And one thing to notice too is that they do not say that these are different integers. Okay? They're just saying that we have 3-digit positive integers. So A and C could be equal. Okay? So that allows for this possibility where A and C are 4 and 4. But it's always good to check that, because sometimes they sneak in a statement that says that they're different integers. Okay? And in this case, they don't say anything about them being different, the digits are in any way different. So we can have A and C being the same. Okay, so here's our possibilities for A and C. And because 1 plus 7 is equal to 7 plus 1, addition is commutative, we can have, our numbers could be 1, 4, 7, or it could be 7, 4, 1, okay, for this scenario. And same way here, we could have 2, 4, 6, and we could have 6, 4, 2, okay? 3, 4, 5, and 5, 4, 3. And in this case, if both A and C are the same, then the only possibility is 4, 4, 4. Because if when we reverse A and C, that's just the same thing. So, so these are our possibilities. Okay, so if you count them up, you can see that we have 7 possibilities. All right, so we can have A, B, C be 1, 4, 7, and then C, B, A would be 7, 4, 7, 4, 1. Or we can have A, B, C, the first number be 741, and with the digits reversed, we get 147. So those are distinct possibilities. Okay, these are distinct integers. Even though the one with the digits reversed is the same, okay, it's still, we can have 741 plus 147. Okay, or we could have 147 plus 741. Okay, so don't let that confuse you that, we're dealing with the same numbers here. These are two distinct scenarios that work for this problem. Okay, so our answer is we have a total of 7 possible 3-digit positive integers that result in a sum of 888 when we add that number and its reversal number, the number with the digits reversed together.